Disk partitioning is the process of dividing a hard drive into multiple logical sections. These sections are called partitions. Think of it like dividing a large house into smaller rooms, each serving a specific purpose. Partitioning is crucial for organizing and managing your data effectively. It also allows you to install multiple operating systems on a single drive, known as dual booting. Without partitions, your entire hard drive would be treated as a single storage unit. This can lead to several problems. If one part of the drive encounters an error, the entire drive could become inaccessible. Additionally, mixing different types of data, like system files and user files, in a single partition can impact performance and make data recovery difficult. By dividing your hard drive into partitions, you create separate, isolated spaces for different purposes. This isolation enhances data security, as a problem in one partition is less likely to affect others. It also improves organizational efficiency, allowing you to allocate specific space for the operating system, applications, and user data. Ultimately, disk partitioning gives you greater control over your storage space and contributes to a more stable and efficient system. In Linux, certain partitions are commonly used for specific purposes. Understanding these standard partitions is key to setting up a well-organized system. Let's break down the most common ones. The root partition, often referred to as the root directory, is the most important partition. It houses the Linux kernel, core system files, system utilities, and essential libraries. The root partition is where your Linux operating system lives. Without it, your system won't boot. The swap partition acts as an extension of your RAM. When your RAM is full, the system can temporarily move less used data to the swap space, freeing up RAM for active processes. This is particularly useful when dealing with memory-intensive tasks, or if your system has limited RAM. The home partition is dedicated to storing user data, including documents, music, videos, and user-specific configuration files. Separating user data from the system files in the root partition has several advantages. It simplifies backups, allows for easier system upgrades or reinstallations without affecting user data, and enhances data security. The EFI system partition, or ESP, is essential for systems using UEFI, a modern replacement for the traditional BIOS. The ESP stores the bootloader, which is responsible for loading the operating system when you turn on your computer. Understanding the roles of these common Linux partitions is crucial for planning your disk layout and ensuring a smooth and efficient system setup. When it comes to partitioning a hard drive, you'll encounter two main partitioning schemes: MBR, or Master Boot Record, and GPT, or GUID partition table. Both serve the purpose of defining the partition table on your hard drive, but they differ in their capabilities and limitations. MBR is the older of the two schemes. Introduced in the 1980s, it has a limitation of handling drives up to 2 terabytes in size. MBR also supports a maximum of 4 primary partitions. While you can create more partitions using logical partitions within an extended partition, this structure can be more complex to manage. GPT, on the other hand, is a more modern standard. It overcomes the limitations of MBR, supporting much larger drive sizes, theoretically up to 9.4 zettabytes, and allowing for a significantly larger number of partitions, up to 128 on Windows, and practically unlimited on Linux. GPT also offers improved data integrity with features like cyclic redundancy check, or CRC, for detecting errors in the partition table. Another important difference lies in how they store booting information. MBR stores the bootloader code in the master boot record itself, located in the first sector of the hard drive. GPT, on the other hand, stores multiple copies of the boot data across the disk, making it more resilient to corruption and offering faster boot times. Section 4. Choosing the right partitioning scheme. Now that you have a good understanding of MBR and GPT, let's discuss when to use each partitioning scheme. Choose MBR if you are working with an older computer that doesn't support UEFI boot mode, your hard drive is 2 terabytes or smaller, or you need maximum compatibility with older operating systems. Choose GPT if you have a modern computer with UEFI support, you are using a hard drive larger than 2 terabytes. You want to create more than 4 primary partitions, or you prioritize data integrity and faster boot times. In today's computing landscape, GPT has become the dominant standard, especially for new computers and larger hard drives. However, understanding both schemes allows you to make informed decisions based on your specific needs and system configurations.